Fix name search in Elasticsearch for typos, sound-alikes, and exact matches. This is the workflow you'll know how to run when we're done, which searches names using phonetic matching and fuzziness to favor exact hits. I'm Professor Pi, teaching search and IR with simple Python. Name search is one of those small problems that becomes big in production. Users mistype names. They use nicknames. Different spellings and similar sounding names create noise. If your search only matches exact strings, you miss people. If it is too loose, you return irrelevant names. The right balance recovers near misses, but still surfaces exact matches first. Elasticsearch is a great fit here because it handles indexing, analyzers, and scoring at scale, so you do not have to build a custom search engine from scratch. At a high level, we will combine 3 ideas. First, analyzers that record both surface tokens and phonetic codes, so sound-alikes line up. Second, fuzzy matching so minor typos still match. Third, ranking that boosts exact keyword hits so perfect matches float to the top. Imagine someone types a misspelled or nicknamed name, and you still want the obvious correct record to appear first. That is the outcome. We will build a small pipeline that connects to a local Elasticsearch, creates an index with a phonetic analyzer, indexes a handful of names, runs fuzzy queries, boosts exact matches, and then expands queries with common nicknames. The code is simple and uses Python to drive Elasticsearch, so you can reuse the same idea in a production system. Now we start by verifying the server connection. Now we will check the Elasticsearch connection. This snippet connects to Elasticsearch locally and verifies the server by reading metadata. The Elasticsearch object, ES, opens an HTTP connection to the default node on localhost. The variable IDX sets a shared index name used by later steps. The call, es.info, returns cluster details such as version, build hash, and cluster name. The version string is extracted into ver, so we can confirm the client and server are successfully talking. If you point the client at a different host or port, update the URL passed to Elasticsearch accordingly. Seeing a concrete version tells us the connection is healthy and ready for indexing and search work. Next, we will create an index that can handle phonetics and accents. This example creates an Elasticsearch index that adds phonetic matching for names. The dictionary and defines a custom analyzer named nameAn that lowercases, removes accents via ASCII folding, and applies the pH filter. The pH filter uses the Phonetic plugin's double metaphone encoder with replace disabled, keeping original tokens alongside phonetic codes for better recall. The mappings set name as text with the nameAn analyzer and a raw keyword subfield for exact match boosts later. A quick existence check deletes any prior index, so creation is clean. The es.indices.create call finalizes the settings and mappings. The printed index confirms the phonetic-ready index is live. Now we will add a few toy name documents and try a fuzzy search. This code indexes 3 simple name documents and runs a fuzzy search in Elasticsearch. The list docs holds tiny, readable examples so we can see how matching behaves. Each document is written with es.index, and then es.indices.refresh makes new data immediately searchable. The query queue uses a match on the name field with fuzziness set to auto and prefix length set to 1, which tolerates edits while anchoring the first character. The call es.search requests the top hit, and the first hit is read into H. Increasing fuzziness broadens recall at the cost of speed and precision. The printed ID and score show the best fuzzy match found. Next, we will combine fuzzy recall with an exact match boost to prefer perfect strings. This snippet boosts exact string matches while keeping fuzzy recall in Elasticsearch. The variable Q2 holds a full name query. The QB dictionary builds a bool query with a must clause for fuzzy matching on the name field and a should clause that targets the keyword subfield name.raw with a high boost. The exact term hit on name.raw significantly increases the score when the full string aligns precisely. The search runs with es.search and retrieves the top document, then H collects the winning hit. Raising the boost increases the separation between exact and near matches. Lowering it blends them more. The printed score confirms the boosted ranking impact. Now we will expand queries to handle nicknames and aliases in Python. This example handles nicknames by expanding the query in Python and leveraging Elasticsearch scoring. The dictionary nick maps a query form to common aliases, and QW holds the user input. The list alts merges the input with its aliases, ensuring we try each variant. The list comprehension QS builds fuzzy match clauses for every alias, which benefit from the index's phonetic analyzer to connect soundalikes. A should term on name.raw boosts any exact alias match, while minimum should match of 1 ensures at least one clause must hit. The es.search call returns the top candidate. The printed ID and score show how nickname expansion recovers difficult queries. Mapping this toy flow to a real project is straightforward. Replace the 3 example documents with your production dataset and add a small alias table for common nicknames. Run the same index settings across teams so everyone shares the same phonetic behavior. Log query latency and hit quality to tune fuzziness and boost values in real traffic. Recap: it is a practical pipeline that uses phonetic analyzers, fuzzy matching, and keyword boosts to recover typos and soundalikes while favoring exact matches. Use it when users search personal names, customer records, or any short strings where spelling varies and sound matters. Caveat: fuzziness and phonetic expansion increase recall, but can bring false positives. So tune boosts and fuzziness for your data. Next step: tune the exact match boost against fuzziness on a validation set so you get the desired balance of precision and recall. If short, practical IR helps, subscribe and watch the IR videos.